This is the chemical equilibrium calculation from the 2019 chemistry leaving cert paper. So it's question 11, part B, part 2. I've prepared my ice table and I'm looking at the data given in the question. I've got 0.2 moles of the reactant in 5 litres, so I'm dividing the 0.2 by 5 to get moles per litre. 0.04 moles of reactant and 0 products initially. The change is going to be minus x, we don't know the concentration, and there's a 2-to-1 ratio between the reactants and the product, so I'm going to lose half that much, or I'm going to form half that much of the products from the reactant based on that 2-to-1 ratio. So I've got minus x for the reactant and plus 0.5x for both products. Now at equilibrium I've got 0.04 minus x. We still don't know x, but we need to find that. And then of the products we've got 0.5x for each of the products. Now I can put that into the Kc expression. So that will be products above reactants, and I've been given the Kc value, so I can put that into the instead of Kc I've got the Kc value, so I've got 0.22 equals, and I've got the products, rather than putting in 0.5 multiplied by 0.5, I've just got 0.5x squared. That's the products, and the reactants, I've got the reactant is to the power of 2 because of the coefficient 2. Okay. Coefficient becomes the exponent. So I've got a square above and below the line, so I'm going to apply a square root to get rid of the squares. So that's applied to both sides. So if I square 0.22, I get 0.469, and the square root on the right just gets rid of the squares. So I've got 0.5x above 0.04 minus x. And to get rid of 0.04 minus x on the right, I multiply both sides by that value. So both sides are multiplied by 0.04 minus x. So there it is on the left, and on the right it will cancel above and below the line. Now I multiply that out to simplify it. And I move all the x values over onto the right. So I've got the value of 0.969x, and to get the value of x I need to divide both sides by 0.969. So above and below the line will cancel out, so I'll just have x on the right, and that will enable me to get the value of x. And we get the value of x is 0.0194. So what are we asked in the question? If we have a look, we're asked to calculate the percentage decomposition into the products. So we need to find out the percentage of x, the percentage that represents of the initial concentration. So we'll put 0.0194 over the initial concentration of 0.04 and get the percentage of that, 48.5%. And we're asked in the question to express this as the nearest whole number. So that's the nearest whole number, 49%.